Welcome back to Spice. In this session, we'll continue with instrumentation, question and answers. In part one, we'll focus on pressure transmitters. So possible questions, interview questions from pressure transmitter. Okay. So pressure transmitter, as you all know, works by measuring the force that fluid exerts fluid or gas exerts on a sensor, right? Here, this one, right? The fluid, whatever is act or, exerts on the sensor element in the transmitter and converting that measurement into an electronic signal that can be read and interpreted. So it works by converting the applied pressure into a proportional electrical signal, typically accomplished using a strain gauge or piezoelectric sensor. That depends on the types of application. Okay, so this is about the funda. Okay, so what are all the possible interview questions? Friends, maybe one of the questions, okay, see, you have an instrument range, right? For example, your instrument range is 0 to 10 bar, okay, pressure transmitter bar. And how to, set the calibration range. So it is not necessary that you have to calibrate from 0 to 10 actually. See, you have to calibrate in line with the maximum operating pressure. So that is a point. For example, even though the instrument is 0 to 10 bar, your maximum operating pressure is 6 bar. Then you calibrate to 0 to 6 bar. Okay. So this could be one of the possible questions. And there are many more actually. Okay. So what is a pressure transmitter used in industrial application? Okay. So where it is used actually? So basically, pressure transmitters are primarily used for what? Measuring fluid pressure in various applications such as oil and gas, chemical processing, and water treatment. This is very simple. Okay. Okay. So which type of pressure transmitter is typically used for, high temperature? So which type of transmitter is typically used for high temperature application? So basically, there are a lot of types: piezo resistive, capacitive, strain gauge, vibrating wire, all these. So the answer for this question, high temperature application, is piezo resistive. These are well suited for high temperature application because they are capable of withstanding temperature up to 500. Okay, friends. So that's the point here. Okay. Then what is the accuracy of a typical transmitter? Nowadays, friends, the typical accuracy is around point plus or minus 0.1% of full scale range. 0.1% also we are getting it. Okay, that is the point. Okay. And what is the response time of a pressure transmitter? See, basically we know response time, right? What is the response time? So the response time of a pressure transmitter is the time it takes for the output signal to reach a steady state after a step change in pressure is applied. I repeat again, the response time of a pressure transmitter is a time it takes for the output signal to reach a steady state after a step change in pressure is applied. So that is the answer for this response time. So what is the hysteresis of a pressure transmitter? Have you heard about this? Yes. So the hysteresis of a pressure transmitter is the difference in output for increasing and decreasing pressure measured at the same pressure value. You got it, friends? The definition of hysteresis, somebody asked what is hysteresis, is a difference in output for increasing and decreasing pressure measured at the same pressure value. So that is the point. Difference in output, okay, measured at the same pressure value. Okay, friends, right? Okay, good to go. Then what is the damping? You would have seen, right? We have uploaded so many videos and in the data sheet and all, right? So we have a concept called damping, right? What is a damping basically? The damping of a pressure transmitter is the smoothing of the output signal to reduce noise or fluctuations caused by vibration, turbulence, and other external factors. Okay. So the damping is nothing, is a smoothing of the output signal to reduce the noise or fluctuations caused by any external factors. Okay. Okay. What factors affect the accuracy of the pressure transmitter? This is something basic actually. See, your transmitter is getting, affected. The accuracy is getting affected. What are the factors can you think? Temperature, pressure, Fluid type? Yes. So all actually, temperature can affect, pressure range can affect, fluid type can affect the accuracy of a pressure transmitter. You got it, friends? Right. Then what are all the common failure mode of a pressure transmitter? Why this, the transmitter fails actually? There are many things actually. One important thing is the sensor drift, which is a very gradual change in the output signal over time. Is a common failure of a pressure transmitter. Okay. So this could be, caused by aging or contamination or mechanical stress. So basically, the common failure, the very common failure in a pressure transmitter is a sensor drift. Okay, friends, you got it? Okay. Then what are all the factors, the response time can be affected in a transmitter. Okay, just think about it, the response time. So the response time will affect if your sensor is a problem, sensor is issue, sensor size and fluid viscosity, and again the damping. Okay, all these actually, the response time of pressure transmitter can be affected by various factors, as I said, like sensor, fluid size, fluid viscosity, damping, and of course the electrical circuitry. Okay, good to go. Then benefit of using a pressure transmitter with built-in temperature compensation. You'd have heard, right? Nowadays, all come with a built-in temperature compensation, right? Yes. So basically, pressure transmitter with built-in temperature compensation can improve the measurement accuracy by compensating for temperature changes that affect the sensor output signal. So that is the beauty actually. Okay, it's improve the measurement accuracy. Okay, friends, good to go. Right. Now, what factors affect the reliability of the pressure transmitter? There are various factors, right? So maybe you can think of, environmental or maintenance schedule or meaning a mounting position, everything, right? So basically, the reliability of a pressure transmitter can be affected by various factors actually. Environmental conditions. What are all those environmental conditions? Temperature, humidity, corrosion, right? And also the maintenance schedule actually, if the calibration is not done in line or as per the recommendation, then of course there is a, the reliability could be affected. Okay, friends, so these are the things. Then what is the common calibration method? How we do the calibration? This is also very simple and basic. Basically, I just want to list out something. That we can use what do you call dead weight tester or a pressure comparator or a master gauge. In olden days, we use master gauge, right? Nowadays, dead weight tester or pressure comparator. Okay, friends? Right. So that's the calibration method. Then type of pressure transmitter suitable for measuring pressure in corrosive environment. Any guess? Type of pressure transmitter suitable for measuring pressure in corrosive environment. Okay, just think about it. If corrosive means you can go for, ceramic or quartz or glass sensing, all these actually. Pressure transmitter with ceramic, quartz or a glass sensing are suitable for measuring pressure in corrosive environment because, these are resistant to chemical attack and can withstand harsh conditions. So that is the point actually. Okay. Then we talk about the factors that affect the rangeability of the pressure transmitter. Okay. So basically, the rangeability can be affected by various factors. It could be of sensor size or could be of electrical circuitry or another important point, signal to noise ratio. So all these can affect the rangeability of an instrument. Okay. Then possible cause if a PT is reading constant value, even if the pressure is varying. The pressure in the line is varying, but your transmitter is reading a constant value. So it could be due to, sensor drift or could be electrical noise. That's why electrical noise is very important. We need to nullify that. Or probably a faulty wiring actually. Okay. All these cases can be a cause. Right, friends? Right. So few more to add on. Pressure transmitter affected by pipe vibration. Is it yes or no? Obviously, pressure pipe vibration can affect the accuracy and reliability of pressure transmitter. How? By causing sensor damage or maybe a sensor drift or maybe electrical noise or other environmental factors. Okay, friends? So the answer is yes. So then again, the very common thing, clogging or blockage affects pressure transmitter. Yes. Clogging or blockage in the pressure line can affect the accuracy and reliability of PT by causing reduced accuracy or maybe a error in reading or could be a false alarm. Okay. So these are the things affect the pressure transmitter. Then now pressure transmitter is showing negative value. So what could be the reason? A pressure transmitter, showing negative pressure reading could indicate reversed pressure ports. The port LP and HP side, right? So that could be reversed or could be a faulty wiring actually. So that could be a reason for negative reading. Okay. Then temperature changes impact in pressure transmitter. How this temperature changes impact the pressure transmitter? Yes, again, the same thing. Temperature changes in the pressure line can affect the accuracy, of course, and reliability. How? By causing sensor drift, maybe electrical noise or offset error, all these actually. Okay, friends. So now, how atmospheric pressure affect the accuracy of a PT? Definitely. Accuracy, atmospheric pressure changes can cause zero drift in pressure transmitter. That's a very, very important point, thereby affecting the accuracy of the sensor output signal by shifting the 0 point of the pressure range. So that's the reason. Right. Now, pressure transmitter is showing high reading actually. So what could be the reason? Yes. Pressure transmitter showing a high reading, even if the pressure in the line is normal means it could be because of the calibration error. So which affects the accuracy and reliability of the sensor output signal. Okay. Good to go. Okay. Then pressure transmitter impact due to changes in process fluid density. How? How the pressure transmitter is impacted by changes in the process fluid. Yes, changes in the process fluid can cause again the span drift in a pressure transmitter, drift in the span, affecting the accuracy of the sensor output signal by shifting the span of the pressure range. Okay, friends. So that could be the reason that PT shows fluctuation reading even if the pressure is constant. So this is a different question actually. See, a pressure transmitter showing fluctuation reading, even if pressure is constant, could indicate again the noise, sensor drift, or loose wiring. So these are the things we need to watch out for. Very simple, but it is useful actually, right? Okay, good. How PT can be affected by over pressure in a process line? See, now we have seen temperature, we have seen pressure, all these. Now I want to see how the PT can be affected by the overpressure. Line is overpressure. Again, the same question, friends. Answer. Overpressure in the line can damage the sensing element of a pressure transmitter, thereby affecting the accuracy and reliability. That's it, a sensor, right, friends? So that is why we have to choose a proper, sensor actually. Right? Yeah. See, normally, I don't know whether you have seen my video on the pressure transmitter design. Normally, if you have, for example, your pressure requirement is only 10 bar and the transmitter will be, designed for at least 1.5 times. So that means 15 bar, your transmitter is capable. So thereby any pressure in the line increase or, that can nullify them. They will not cause any effect. Okay. Then mounting position also affect accuracy. Yes. See, what will actually, it doesn't actually, it affects indirectly, meaning it can cause zero drift and it can cause span drift. That is okay. The mounting position of the transmitter can affect its accuracy by causing zero drift or span drift due to the effects of gravity and mechanical stress on the sensing element. This is on the, longer term, not immediate, but on the longer term. Okay. Good to go. Then pressure transmitter affects due to the presence of bubbles. Bubbles are air packets, right? Yes, again, here also the same thing actually. The presence of bubbles or air pockets in the process line can cause some span drift or zero drift in a pressure transmitter. That's it. Okay. So that is the answer. Then what is this purpose of zero and span? Of course, you know this. The purpose of zero and span on the pressure transmitter is to adjust the output signal to match the expected pressure rate, ensuring the accurate and reliability. That's it. Basically, to adjust the output signal to match the expected pressure rate. That's it, friends. Okay, now our PT, it's already sensor is drift. How PT tested for a sensor drift actually? Any guess? How the PT can be tested for sensor drift? Yes. See, a pressure transmitter can be tested for sensor drift, obviously by comparing its output to a reference standard, right? Reference standard could be a pressure gauge or a calibrator. So determine whether the sensor is accurately measuring the pressure read. That's it. Very simple. And of course, you know the components of pressure transmitter. It is very simple. But anyway, I just want to, give you some insights also. What are the components basically? You have a sensor, which is, here inside, right? Sensor. And of course, your electronics and housing, all this. And diaphragm, diaphragm, bellows, all this. And of course, the inside, yeah, all these basically. Sensor, sorry, not sense. Diaphragm is for this one, DPA, but this is sensor here. This is the diaphragm sensor. And you have electronics and housing actually. These are the main components, right, friends? So again, as I highlighted earlier, basically the sensor converts the applied pressure into a proportional electrical signal, which is amplified and conditioned by the electronics before it is transmitted to the control system. That's it, friends. Okay, then sensor damage in PT. How the sensor, damage, what could be the reason actually? Again, if you talk about the sensor damage, I already highlighted, right? Overpressure, right? And also corrosive or abrasive media. Of course, we can do away with this, by preventing, by adopting, like if it is a corrosive service, you'll go for, a better SS or maybe Monel or, even sometimes gold plated to avoid, corrosive things. All these aspects can be done. In fact, hostile IC, everything can be done. But just listing out the potential causes. So could be overpressure or corrosive, temperature, or even physical impact or vibration. Okay. Then another important point, friends. How can the electrical noise or interference minimize in the PT installation? What we can do? Yes. So we can do this electrical noise or interference in a pressure transmitter can be minimized by using shielded cables. You know, right? Yes. And grounding in the transmitter and associated equipment, installing a noise filter or surge protector. That's right, right? So nowadays we also ask for the surge protector, right? Thereby adjusting the transmitter's gain and filtering setting as needed. So that is the, remedy for this. Okay. Then which type of pressure measures relative to perfect vacuum? Any guess? Which type of pressure transmitter measures pressure relative to perfect vacuum? So the answer is absolute transmitter. You would have seen, right? Absolute, gauge, all these, right? Yes. So the absolute pressure transmitter measures the pressure relative to a perfect vacuum, which means that they measure both the pressure of the process media as well as the atmospheric pressure acting on it. So that is the beauty. If you want to know the, meaning of absolute pressure, gauge pressure, I have uploaded a video exclusively on this. Okay, the basics. Okay, friends, right. Good to go. Few more to add on. Which type of pressure transmitter measures pressure relative to atmospheric pressure? So there we talked about the pressure relative to perfect vacuum, which is absolute pressure transmitter. Now we are talking about pressure relative to atmospheric pressure. Okay, what is that? It's a gauge pressure. So gauge pressure transmitter measures the pressure relative to atmospheric pressure, which means that they measure the pressure of the process media minus the atmospheric pressure acting on it. That's the beauty. In perfect vacuum, we have seen absolute pressure transmitter. That guy actually measure the pressure of the process media as well as the atmospheric pressure acting on it. Whereas here in this atmospheric pressure, in the gauge pressure, it basically measures the pressure of the process media minus the atmospheric pressure acting on it. So that is the difference. It's only the gauge pressure. Okay. Right, friends? Good to go. And which type of PT commonly used in level measurement application? Of course, you know that, right? What is this? Basically, differential pressure, right, friends? Right. So we use a differential pressure type for level application. So that's all, friends. These are the things came to my mind, and of course many more. But yeah, I hope this is enough for get basic concepts about the pressure transmitter. See you in the next video. Okay, thank you. Take care. Bye bye.